Thanks a lot. All right, thanks a lot for being here. Most years, this is like the 6th or 7th time that I've done this. It's been a while because, of course, we've got a few years off here. Most years, I think people go down here primarily because it's an air-conditioned facility. Usually I'm down there. So this is very encouraging. Thank you very much for joining us here today. I am Tom Turner. I am, a lot of you know me, my day job, the real what pays the bills. I'm Executive Director of the American Banana Society's Air Safety Foundation, which is a lot to say. I run all of the educational and technical programs and create most of the educational content for our membership of over 10,000 owners, operators, maintainers, and enthusiasts of Beechcraft airplanes around the world. So if you want to get a hold of me, that's one way to get a hold of me, through bonanza.org. I also, as Brent said, I have, I guess you call it a blog. I tried to resist calling it a blog. Tried to be a little bit more grandiose for a while. It's a publication, but that's a blog. I do a blog called Flying Lessons Weekly. It usually comes out Wednesday or Thursday night. I did Thursday night this week because it got busy this week. But nonetheless, in Flying Lessons Weekly, what I do is I look at recent accident reports or the sorts of things that you all are discussing online in hangar flying sessions about what might have happened to somebody in their airplane recently. And I try to draw the positive lessons out of what we could learn from those mishaps. That's what we're working on here today. Specifically, if you read one of these when it comes out, there is a long, it's not really a disclaimer. What it's really saying is that we don't know. At the time that we are usually discussing an accident report, almost always immediately after it appears in the news, right after it happened, we don't know what caused that accident. There may be a year or more of investigation that needs to go into determining what might have been the probable cause of that mishap. However, the facts that we do know at that point can give us an idea, not necessarily what caused this accident, but it can be a reminder of the things that we need to think about every time we fly so we can avoid this and similar types of mishaps. So I'm going to look at 3 accidents, and I apologize up front if you know personally some of the people involved in these mishaps. They are very tragic events. I never want to forget that not only was there one, or in one of these cases, 3 people who perished in this terrible accident, but there was an entire circle of family and friends and co-workers and perhaps people whose employment depend on that person and their families. There's a huge pool of tragedy that applies to all of these mishaps. So I get analytical. I don't mean to be critical. I want us to all learn from these things. So as we look at these, let's talk about the things we might learn from the facts of these mishaps. The first one we're going to talk about is the Snort Snodgrass accident in a turboprop built in Italy that is essentially a turboprop version of a Cessna 01 Bird Dog or L-19 Bird Dog. It happened in Lewiston, Idaho, July 24th, just about a year ago, and it received a great deal of press at the time. The final NTSB report on this came out about a week or 2 ago, and there has been a resurgence of discussion because, I think in large part because of the prominence of the pilot involved, we've had this second discussion about it. So we're going to look at what I saw even when I first read about this mishap a year ago, and how we might apply that to safely flying ourselves as we leave here and for the rest of the years we fly our airplanes. So let's look at this. The NTSB has issued a probable cause report on this. This is the end of the investigation. This is the final statement of what was felt to have been the primary cause of this accident. Pilot's failure to remove the flight control lock before departure, which resulted in a loss of airplane control and impact with terrain. Contributing to the accident was his failure to perform an adequate pre-flight inspection and flight control check before takeoff. So that's what they determined to be the case here. And there are photographs in the docket, which is the NTSB's collection of paperwork and mass during the process of creating this investigation. They have photographs of the control lock. Now, it's not like the control lock that most of us have on light airplanes, which is a device that goes outside or maybe a control wheel. In this particular airplane, it was a lock that rose up between the rudder pedals in the front of the airplane. And some of the pictures, when the lock is engaged, you can barely see it when you're sitting in the airplane because your knees and the control stick are in the way. But there are ways to detect that, of course, even if we don't visually see it. So I saw this original discussion a year ago and started to think about these things. First, what do we know about the pilot in command? He was a retired naval aviator of great prominence. I believe he is credited as having more F-14 times than any other pilot. He was a demonstration pilot for the Navy flying F-14s. He flew here in F-14s. He flew air shows as part of the Navy's recruiting process. And he's also a popular jet performer, air show performer after his retirement from the Navy. So we've seen him here several times and lots of other things. He's got a huge amount of experience flying aerobatics and military aircraft. He held his civilian ratings for commercial IFR, CFI, II, 6,500 total time. Now you think, gosh, this guy's, he flew an entire career. He was the highest time F-14 pilot in the Navy. Remember, in tactical flying, you're lucky to get 45 to 50 minutes of flight time on a particular mission. They very rarely fly very long missions. They fly lots of them, and they're very demanding and very precise, but you don't get a whole lot of the total time count. It's very high quality time. He had about 20 hours in the make and model. He was 72, which may or may not have had any bearing at all on the mishap, and the NTSB did not investigate that at all. The accident sequence. The airplane was at Lewiston. He was taking it to his private home airstrip. I think it was only about 20 miles away. The NTSB docket interviewed his wife. The investigators interviewed his wife. She said there was no time pressure. There wasn't any weather coming in. He didn't have to get there in time for the grandson's soccer game or anything like that at all. There was no time pressure on this flight. There's no record of the pre-flight, and all that means is we do have video record of the final courses of this flight. There just wasn't any camera that happened to be pointed in the direction of the ramp or the hangar that would show how much time he might have devoted to a pre-flight inspection and or whether or not his buddy may have walked up and interrupted him in the middle of a pre-flight inspection or something like that. We do know from the video that he did an intersection takeoff. There was tons of runway ahead of him. That wasn't a factor. This is a very short field airplane anyhow. The aircraft rolled about 400 feet before it pitched up excessively from a 3-point attitude. It pitched up to 45 degrees nose up approximately, made it about 80 feet into the air, and eventually rolled off about 90 degrees to the left before tragically impacting the ground. You've probably seen, if you look at such things, there was actual video posted online of this. I think ALPA had it on one of its programs. I don't have the video, but this was in the NTSB docket. This is a sequential series of photographs taken from the video. This is approximately 3.6 seconds worth of flight on this airplane, where it pitched up excessively, rolled off to the left, and unfortunately impacted the ground. So when I first, when I saw this, and again I revisited it in the recent flying lessons after the video came out, but when I first saw this last year, I thought about another similar sort of mishap. I had a good friend, he was an airline pilot for Spirit, Tom Kamen, good friend. He worked with us, the American Bonanza Society, in our display at Sun and Fun every year. And my younger brother decided to make an age 50 mid-life career change to be an airline pilot. He kind of mentored my younger brother into his airline flying experience as well. Tom and a good friend of his, Tom was not an AMP, his good friend was an AMP, but they were both very experienced in maintaining airplanes. Tom did a lot of stuff and then got it signed off. They had spent several years restoring a PA-12 Micro Super Cruiser. This one's in the National Air and Space Museum. I couldn't find a picture of his when I was putting this together here. But they put this all together. It took several years, I think 7 years to get it all put together. And I remember it was Friday morning of Sun and Fun. He was so excited because the next day they were going to do the first flight the first post-restoration flight on the PA-12. And then a little bit, Saturday afternoon, we heard the awful news that he had died in a crash of the airplane, and they had determined pretty quickly that his elevator control, had been hooked up backwards. So this would be the pull up, this would be the nose down. And he had a very similar profile to what we saw on the Marchetti crash. As soon as the airplane attained enough speed to develop enough lift, it pitched up excessively, and then because the pilot had no control over pitch at that point, it rolled off and it had a very similar outcome. So when I first saw the Marchetti crash a year ago, my first thoughts went back to this and back to what I thought and wrote about that back then. And so what I did in Tom's case, and I reiterated in my blog in the case of the Marchetti, was ask myself what I always do when I see an accident report. What might have caused that? We don't know yet, but what might have caused that accident? And more importantly, knowing what might have happened, what should we each consider every time we fly an airplane that we can learn from this tragic experience? So some of the lessons I came up with, let me ask you. All right, I put that one up. I meant to ask you all first. What pops into your head? We know that in the Snodgrass accident, they found the control lock. But what other things might cause an airplane to have a similar sort of profile on takeoff? The control lock would be one of them, incorrectly set trim. What else might cause it?
Weight and balance.
Weight and balance could be an issue. What else?
Cargo shift.
Seat belts and maybe pulling back or something like that. Somebody said something on
Cargo shift.
A cargo shift. Cargo shift. There was a phenomenal video several years ago of a 747 cargo taking off out of Afghanistan and a cargo shift. And it did about the same thing. What else?
Seat sliding back.
Seat sliding back. What did you say? Same thing? Same thing. The
Something
seat,
in the control. Something blocking.
something blocking the control. These are all things that might have happened. And so this accident reminds us to mitigate the risks of those possibilities. So I came up with a bunch of things that might have happened. And in this order, this is what I wrote in my initial discussion of the Snodgrass accident. Number one, incorrectly set trim. Number two, control lock left installed. Turned out that's what they found out was the case. Object in the cabin interferes with the control movement. You can't get to stick back or forward. I've flown in airplanes where, or I got ready to fly, and then we modified it before we flew. I've been in airplanes where there is an aftermarket push-to-talk switch on the yoke, and the way the wire was routed, you couldn't get all the way back with the control without, you ran against that. A friend of mine has a beach detonator that when he bought it had an angle mount for a handheld GPS that you could plug into the panel, but guess what? It was perfectly okay when the airplane had the standard Beechcraft single yoke, but with the dual yoke installed, you couldn't get full nose down with it, so they had to modify that. I've seen water bottles rolled off the co-pilot seat down into the rudder pedals that might obstruct something. I've gotten in airplanes sometimes when my wife likes to ride the back of the airplane. She has some mobility issues. It's easier to get back there in one of the Bonanza that we fly that has the big double back doors. So I sometimes will, if I've got a couple people back there, I'll put some suitcases on the co-pilot seat. And I put it in the wrong way once, and when I tried to do a control check, I couldn't get out, so I had to spin it around. Lots of different things can cause the controls to be inhibited. I flew with one very large person one time, and I couldn't get full out of control with this very large person over there, so we couldn't go flying. All right, it happened. So that could be a possibility. Rock, snow, ice, or some other foreign object interferes with control movement on the outside. You get a rock or a piece of ice is usually the problem. In the elevator or the aileron hinge line, or maybe the rudder, and the control cannot move through its entire range of motion. So that's a possibility in a case like this. Other thing, the seat comes unlatched, and at rotation, the seat slides aft. You're hanging on to things that if you slide aft, you're going to pull back with you, and the airplane noses up. That could happen. Electric trim runaway, if the airplane has electric trim, and it chooses at that point to start to activate on you. I actually had that happen to me in a Beach Bonanza. It went nose down instead of nose up, but there's a procedure for that. There's an emergency procedure, and I practiced it enough to just click, and I did it. But that's a possibility. Elevator control cables reverse, like my friend Tom in that PA-12. Control stick becomes disconnected. It comes off in your hand. You know, it sounds like a cartoon. I guess that could have been a problem if you had a corrosion problem or something. Overly aggressive pull-up, either intentional or otherwise. All right. This was Captain Snodgrass was an air show performer. Maybe it was like, whoa, let's show the people the show. I'm not saying that was it, but it was a possibility. And we see it in mishaps, especially not so much on initial takeoff, but the guys that like to do the high-speed buzz down the runway. You can decide whether that's legal or not in a different forum, but then do a rapid pull-up at the end, and that could do it. I had even more possibilities. The airplane loaded after out limits, or a cargo ship. Both of those I thought about and wrote about back then. And then lastly, possibly a pilot medical issue. So any one of these things might have caused either of those two accidents I talked about so far. We didn't know at the time we began this discussion. And at the point where we're all online chatting about these things, usually we don't know. But you can start to think about what might have happened and therefore what I can learn about it. So we've got a list of 12 things here. I also published in that same blog mitigations for these things. How can we protect ourselves? If we're going to learn something, we need to learn some way to avoid it. So what might we do to avoid it? Well, the first mitigation here applies to number 1 and number 6. Incorrectly set trim or an electric trim runaway. Use your checklists. Now, you may be flying an airplane that's extraordinarily simple, and you may be flying a home built that doesn't have a published checklist, or you're out there in an Aranca Champ and there's not much in the way of a checklist. But if you don't use a printed checklist, at least use a well-practiced procedure. Sometimes they talk about flow checks. I like to do a flow follow with the checklist, but nonetheless, use some technique every time you fly to check these things. Right? So follow your checklist. Notice also, at least in some types of airplanes, the position of the trim tabs for takeoff may vary under different conditions. So check it out in your airplane's manual to see what's appropriate for your aircraft and see if it changes based on the distribution of weight of the aircraft. To protect yourself about maybe autopilot-driven or electric trim-driven operations, look at the supplement and the owner's documents, the owner's manuals for any autopilot you have installed in the airplane. There will be a pre-flight check. It's not usually in the POH of that airplane because not every airplane has that particular system on board. Now, if you have a fairly homogeneous fleet, there are like 5 or 6 flavors of Cirrus, for instance. Each one of those is going to have basically the same equipment in every airplane, and they're all new enough that, for the most part, they don't have a lot of aftermarket equipment on them. So maybe the airplane flight manual, I think the airplane flight manual for the SR-22 has this included in the before takeoff checklist. But it may be that this information is in a supplement, and you have to look into the supplement and add those steps to your before takeoff checklist. And then lastly, there is going to be, if you have an electric trim, whether or not there's an autopilot, if you have an electric trim system, there is going to be an emergency procedure to deal with an inadvertent movement of that electric trim. There's an electric trim runaway procedure. Now, in the beach airplanes, it's a little different in some of them have it in the POH, most of them are in the supplement. Here's my story about that. I started teaching in beach bonanzas in 1990. I was at Flight Safety International in Wichita Beach Field. And I taught for 4 years in that program. I've been teaching in the airplanes the whole time since, but I taught for 4 years, and we had a simulator there. And I think it maybe was on day 3 of the 4-day simulator syllabus. The pitch trim runaway was part of the one of the tasks we did that day. And we taught it, and the pilots experienced it, and they learned how to deal with it. And what you do, the first thing you do, there's a big red button on the yoke. You push the button and hold it down. It's called the autopilot disconnect trim interrupt. It will disconnect the autopilot if you hit release, but it will interrupt electrical flow to the trim the entire time you hold it. So you hold that down. You're still flying the airplane. You've got an airplane now that is out of trim because it had a runaway. It's nose up or nose down. I want way nose down. Reach over while you're still looking out here flying the airplane. Turn off the pressure, still holding the button. Then you have to remove electrical power from the trim system, which in the case of the Bonanza is either this is what I teach folks, either the 2nd or the 7th circuit breaker from the right, unless it has an aftermarket system that's put somewhere else. And so you have to reach over and pull that breaker. We had a technique when we flew with pilots that when you first got in the airplane to begin a flight, we had them go through that process. Sitting here looking out the front of the airplane, hang onto the yoke, push the button, move the trim wheel, reach over and pull the breaker without having to look for any of that because you're busy flying the airplane. It's the one circuit breaker you should be able to find without having to look for it. And I always did that myself. So, 25 years I did that every time I got into this type of airplane before I would start my before-start checklist. I was going to an event, one of the ABS events. I was flying an airplane that was part of the Beechcraft Employees Flying Club, so it's over at Beachfield, which is on the east side of Wichita, Kansas. I was going to fly across town to Wichita Eisenhower Airport, which is on the west side. That's where our office was at the time. Pick up my coworker, load a bunch of stuff, and then go on a trip. And I distinctly remember that morning getting in the airplane at Beachfield before I hopped across town, going through this procedure, and I, honest to goodness, distinctly remember thinking at the time, I've been doing this for 25 years, this is a waste of time. Hopped across town, loaded things up, got the airplane ready to go, cleared for takeoff, runway 19 left, we're taking off, got in the air, I wasn't even high enough, I retracted the landing gear yet, and all of a sudden, I must have bumped the switch or something and it shorted because the airplane pushed down radically. And without thinking about it, push the button, trim off, hold it back, push the button, trim off the pressure, pull the breaker. My buddy Whit in the right seat, he said, I knew something was wrong, I just needed to stay out of the way. And my point there is that if you have that kind of equipment in your airplane, or there is another thing that you do routinely that's often before takeoff checklist or any other checklist, and you ever think that doing that before you fly or when you fly is a waste of time, that's one of the most important things you need to remember to do every single time. It took me 25 years until I needed to do that. Then I needed to do it right now and do it right. So that's another lesson we can learn, a mitigation we can learn from this and similar types of accidents. All right, there's a whole slew of them here that all fall into the next category. The control lock's left installed, object interferes with control movement. We have something out in one of the hinge lines that prevents control movement, or maybe the elevator control cables are reversed. These all have a very similar sort of mitigation. The first is to do your pre-flight inspection, and when you do so, pay close attention to not only the movement of control surfaces, but the proper movement of control surfaces. And what I mean by this, let's say you're doing a 172, or I'm doing the Bonanza. You go out, you're out on the wing, and the aileron goes all the way up, all the way down, runs smoothly. There's no nothing inhibits it, it doesn't get rough at any point, it runs smoothly. But also, if I put the control wheel up, if I can see into the cabin, if I put the aileron up, if I can see into the cabin, the control wheel goes to the right. We're going to come back to that in a minute. And if I can see all the way to the other side of the airplane, the other aileron goes the other direction. When you get back to the back of the airplane, the elevator goes all the way up, all the way down. But also, if I have the rudder right here, I can hang on to both sides and make sure that there's no differential movement. It's not loose if you try to wiggle it like that. So make a deliberate check of the security and the proper movement of your control surfaces during pre-flight. We all learn to do that, but it can be easy to forget. I was on a flight instructor check Facebook group recently, and somebody popped out a question that said, what is the most common discrepancy you see when you fly with pilots? Now, I've done 3 endorsements for check rides in the last 30 years. That's not what I do. I do transition training and recurrent training. Most of the time, the pilots I fly with are very experienced, often very experienced in that individual aircraft. And I'm there to do a flight review with them, or they're learning some new avionics. But that's the flying that I do. Also, in the program I'm in, the ASS pilot training program, we get a flight review, they get a flight review, and I can see if they perform the standards and such. But they don't have to do that. They can do that with their local CFI. So the ones that participate with us tend to be self-selecting. In other words, they're the ones that are going to go beyond the minimums anyhow. So you'd expect we've got experienced pilots that, by the simple fact that they're participating in this somewhat advanced type-specific program, are probably the ones that are more oriented toward flying safely. And yet, the thing I responded in that Facebook group is the thing that I see, the most common discrepancy I see among pilots that I fly with, is failure to perform a proper control check before takeoff. We get to the point where the checklist says control's free and correct, I'll see them back, wiggle, wiggle, okay, we're good. Everything's looking in here, and they just, or occasionally, I'll get somebody who blows past that completely, and I have to stop them. And in both those cases, I show them how to do a proper controls free and correct check. And there are 2 steps there. They're free, but they're also correct. So there's your yoke over on the far right of that slide. If you push it forward, or a stick, also, if you push it forward, the elevator is going to deflect down. So push it forward and look that the elevator is down. Now, if the airplane's just coming out of a major restoration like that PA-12, or coming out of the shop, or it's a type of aircraft that you can't see the rudder from where, the elevator from where you sit, have somebody outside confirm for you that the controls went the way they were supposed to. Once you've confirmed it, that at least things aren't hooked up backwards, that the airplane's not been in the shop, it's not going to get hooked up backwards overnight out in your own hangar. But anyhow, push it forward, check that the elevator goes where it's supposed to. Roll it all the way to the left. Now, whether you have a control wheel or a stick, whether you're holding it with your left hand or your right hand, if you stick your thumb up, it will point to the aileron that goes up, and the other one goes down. So I've got the elevator all the way forward, stick goes to the left aileron is up, right aileron is down. Pull it back, elevator comes up, left is still up, right is still down. Nothing inhibited the movement, it didn't hang up somewhere along the way. Roll it the other way, and now the right aileron's up. Left one's down, elevator's where it was, push it that way, didn't hang up, it didn't, nothing changed except the elevator went down, that one's up, that one's down. So that's how I do a control check. It's sometimes called a box check, because or mixing the stick, they used to call it. But just all the way forward, over, that's up, that's down, all the way back, that's up, that's down, elevator's up, all the way, that one's up, that one's down, that way, okay, that one's up, that one's down, and the elevator's down, wiggle it, straighten it out, and then wiggle the rudder pedals, make sure that they go, the rudder goes left and right as appropriate. And now you have checked, if you do this box check, you have moved the controls through every possible range of motion that they can move. And so if there's something that's going to block it, you'll catch it. So now you know that the controls are free. And because you have actually looked outside of the airplane and evaluated the airplane's response to your inputs, you know that they are correct. That's the most common discrepancy I see among pilots. They just don't know how to do it, or they know how, but they don't bother to do a proper free and correct check. I do it 3 times before a typical takeoff. First thing I do is I do a control free and correct check when I first get into the airplane before I start my before start checklist. If there's a problem with the flight controls, I might as well find it out then before I bother starting up the engine and maybe glossing it over later and getting myself in trouble. So I get in the airplane and I do a control free and correct check right away. I'll usually go ahead and do it again in the run-up area during the before takeoff checklist, just as a matter of professionalism, even though I've done it before. And then I like to do it one last time just before I enter the runway for takeoff. Because if you had been taxiing around in slushy conditions or over some gravel, or anything got into one of the hinge lines, especially in the tail dragger back on the elevator, you want to catch it. If you blocked it in some way between the run-up pad and the runway, you want to catch it. Also, this last check, if you get in the habit of always checking the controls just before you take the runway, you'll protect yourself on those days that you do multiple hops. But you don't shut down the airplane. You're going around the traffic pattern. You land, you taxi back, do a control check, or even if you're doing a stop and go, do a control check. Make sure I didn't pick a rock up in the middle of this taxi back, and off you go again. So check your controls. They're free and correct. That's the most common discrepancy I see, even among self-selecting experienced pilots. There was an accident of a Gulfstream 4 in Bedford, Massachusetts back in 2014. 7 people died when the airplane, during an attempted takeoff, roll went off the end of the runway. The NTSB investigated this. They made what was at the time of the first ever and very unusual recommendation. Normally the NTSB will make recommendations to FAA to enact regulation or policy to mitigate the reason for the accident. And they did that in this case. But they also, for the first time, they tasked the National Business Aircraft Association, NBAA, to come up with, to investigate this themselves and come up with some mitigations. And there's a big report on the NBAA website. You can Google it if you want, that details the NTSB's investigation and then NBAA's investigation into it as well. What they found was, because this many airplanes in this class have cockpit recorders, not the voice recorders, but the data selectors. They could tell what happened with the controls, not only on the accident flight, but on prior flights where the data had been recorded. And what they found in this case is that same flight crew had flown that airplane 175 times that were collected on the data recorders for the aircraft. And that same flight crew had not done any before takeoff control check in 98% of those 175 flights. And what had happened was the flight controls were locked. There's a mechanical lock on the pedestal now. Yeah, it looks a lot like the flat handle, and there were some things like that. There were some other mitigations because of the design of it. But what they found was the pilots had simply become complacent about doing the checks and allowed themselves to fall into what an attitude called normalization of deviance. And what that means is doing something wrong or failing to do something right, but nothing bad happening. So it reinforces the fact that you don't have to do it. 25 years I didn't have a pitch trim runaway, which would absolutely reinforce that I don't have to remind myself how to do that procedure before every takeoff, and then it happened. So what you need to do to combat these things, instead of thinking about nothing has ever happened, nothing bad has happened before, think in terms of nothing bad has happened yet. And the way I avoid this bad thing is, in this particular case, doing my controls free and correct. Check every time. All right, another situation. Seat comes unlatched and the seat slides rearward, causing the pilot to pull back on the control. Several types of airplanes have an airworthiness directive or other maintenance information specifically addressing this issue. A lot of assessments that had elongated holes over the decades of flying and everything, and eventually there's a seat stop thing. So there's an AD. If you get an AD, or even if you see a non-mandatory service bulletin or service instruction that relates to seat positioning, go ahead and accomplish it. We have to if it's an AD, but be serious about maintaining those things, inspecting them like you need to, and modifying them if you have to. In any airplane, when you sit down, you're ready to debuckle, kind of rock the seat a little bit. Make sure it doesn't move anywhere. I've been in bonanzas and bearings that I wasn't quite in, the pin wasn't quite in the hole, and the seat would slide, but you don't want that to happen. So that's how you mitigate that. Just when you sit down in the airplane, rock the seat. Make sure it's going to stay where you want it to be. All right, control stick becomes disconnected. Was one of those causes that might have happened that I came up with. So as you're doing your control check, if it feels weird, look into it. It feels like a little sloppy, or it's not going as far over as it's supposed to, or something. Look at the mechanism down here as best you can. See, well, maybe is it corroded? Is it about to break off, or whatever? So if it feels different, look into it. Don't just think, okay, well, I'm not going to worry about that. The controls move the way we're supposed to. It might break off, especially in an older airplane. It's been stored outside. Sort of overly aggressive pull on the controls on takeoff, intentionally or otherwise, to cause an excessive pitch and eventually exceeding angle of attack of the airplane stalls or rolls into the ground. Two things you can do about this. The first is to know the proper attitude for takeoff. Airplane performance is the result of power plus pitch attitude plus airplane configuration. You've got the airplane in the takeoff configuration. Hopefully you've got the power you expect, and you can confirm that at the beginning of your takeoff roll. So it's all about attitude. There is a consistent attitude for every airplane, from a Piper Cub through airliners. There is a specific attitude that will result in the desired performance. And if you're trying to do a VX takeoff, there's a particular attitude. If it's a VY takeoff, there's a particular attitude. That will vary somewhat based on density, altitude, and maybe even weight of the airplane, but not a whole lot. Learn what the attitude is, whether you're looking at an attitude indicator as a backup to the outside world, or simply saying, okay, I'm going to pull the nose until the cowling line's up on the horizon line, and that's a normal takeoff. Hit the proper attitude every time. So the first way to avoid, to mitigate the danger of this possibility is know the attitude. The other way to mitigate this is to control your attitude. All right, you know what I mean? All right, we don't have to be showing off like this. You can make a really spectacular, perfectly VX departure in something like that Marquette. I'm not saying, obviously we know in that case it was a control custom. Or you can do the same thing in, I love ultralights, watching ultralights fly because they fly almost vertically. And the angle's steep because they have no forward airspeed. But it's spectacular even when flown correctly. So if you want your friends to see how great you are, fly the airplane as precisely as possible. That's what you want them to know you're doing. All right. Other possibilities: the airplane loaded aft out of center of gravity, or the CG shift. Another common discrepancy I see among pilots become less of an issue in the last few years is knowing the weight and balance of the aircraft. Now, if I were to take of our 10,000 members, if I sent them all a test to say, okay, using the pilot's operating handbook information only and the empty weight moment of your airplane from your POH, compute weight and balance, I'd have a lot of people head scratching, trying to figure out how to do it. You gotta know how to do that sort of thing, and I sometimes bring that on. If I were in the business of teaching flight instructors anymore, I would be requiring that every single time. Show me you can do it by hand. But there is a plethora of software out there that can do these things for you, and it's really quick and easy. If you happen to fly Bonanza's Barons, Cessna 172s, or TBM airplanes, the turboprops, not the Avengers, there is something called the Performance app, Bonanza Performance app, TBM Performance app, 172 Performance app. It's free in the App Store. I know the guy who's an ADS member who made these things up, and this chart comes from that. You plug in the data, you set up an envelope for your own airplane. There is no excuse for not knowing the condition of your airplane as far as weight and balance is concerned. It also does performance. It's really cool. Takeoff and landing distances. And then, of course, secure your load. This is something else that, I'm guilty of this sometimes too. Being a little lax about just throw the suitcases in the back of the airplane. Make sure they're not going to move. Nowadays, I'll put a suitcase or something on a seat. If I put something on a seat, I wrap the seat belt around it so it won't slip off when I snap the seat belt. I hold it in place there. But secure your load so you don't have this weight shift problem. And the weight shift problem could be just as critical in a 172 or even a 150. If 150s are almost always overweight. You got to watch that out. But in any event, know and secure your load. All right, pilot medical incapacitation, it happens. Now, there is very little good data. There's been very little science into the effect of aging on pilots, except for studies for pilots under the age of 65 who are professional pilots or full-time airline types and that sort of thing. So there really isn't any data. I'm not going to get into it now a whole bit about getting insurance as you're an older pilot, and we deal with a lot with that at work. But there's no real science one way or the other. But it's up to you to make sure you're medically qualified on any given day for any given flight. First thing you might think about, maintaining your medical accreditation, if you will. Keep your medical certificate current. If you're on basic med, follow basic med rules. Initial indications are that there hasn't been any degradation in safety as a result of the introduction of basic med. So keep yourself certificated in whatever way you're doing it. Self-certified before every single flight. You can use the I'm Safe model, but mainly in this context, focus on illness and medications, especially. There are lots of over-the-counter medications that will affect your cognitive abilities or make you drowsy or affect your motor skills. If there's anything the whoever says do not operate heavy equipment, you're not really talking about bulldozers. You're talking about cars and things like airplanes. But the most important element of medical self-certification is to be honest with yourself. All right, this is the hardest part. Well, I feel kind of down, but gee, I really wanted to go to St. Louis this weekend or whatever. Just be honest with yourself about your medical status, and at least, maybe not any hard data. Like I said, there's not a lot of data on this out there. Usually, if somebody has a heart attack in an airplane or a stroke while they're flying or something like that, if you talk to the family, yeah, he's been having some problems for the last few years. The actual incapacitation event may be very sudden onset, but usually it doesn't come without some prior warning. So if you're starting to see some signs of that now, start treating the situation now before it might become a disqualifying condition and certainly before it becomes an incapacitation. So that's what I did with this particular Snodgrass mishap and the PA-12 accident that preceded it. I'm not, Greg Fife was in here before me, unfortunately, so he's a past NTSB investigator. He does all sorts of podcasts and such about aircraft investigation. I am not an aircraft accident investigator. I'm more of an aircraft accident interpreter, if you will, and I try to learn the positive things I can from a tragic situation. So that's what we did with this one. 12 different things that might have happened here. I just want to learn things that I can do on every flight that will help me avoid any one of the possibilities that occurred in this mistake. Nothing bad has happened yet. And if I keep following those mitigations, nothing bad should happen. All right, we're going to talk about another one now. And this one also got a lot of press, a lot of video. Again, I apologize if you are connected with the people involved with this in any way. It was horrible. It was tragic. I owned a Cessna 120, which is the same as a 140, except no flaps and originally no electrical system. So I look at that and think of where I was flying, how I was flying 35 years ago, and wondered about it as well. But this one happened in Wayne, Nebraska, May 20th of this year. This one has not yet gone beyond the preliminary accident investigation phase. Everything now is still in this learning process and investigative process. All right, background, the sequence on this one, there was an event called Skull Drag. They've gotten very popular in the last couple of years. It's a short field landing, stop as fast as you can, turn around as fast as you can, and take off again. So it's a measure of short field landing plus short field takeoff performance. It's a competition. And this was part, the group had collected in Wayne, Nebraska to hold one of these events. The winds were too strong for the criteria, for their safety criteria for holding this event. It was a crosswind, but several of the participants on their own, outside of the organization of the Skull Drag, decided, let's just do a short field landing contest. We're all here, let's just have fun doing it. So it became a somewhat more organized version of the Saturday flying where you do flower bombing and try to touch down on a line on a runway sort of thing. So it was an impromptu thing that was not an organized event necessarily. The pilot involved was extremely well known, popular on YouTube channels, a lot of really good safety content, and also experienced and well known in the Skull Drag school. He was, when the accident occurred, he was one of 5 airplanes in the traffic pattern at the time. Now, if we flew into here, you think, oh, that's nothing. But he was one of 5 airplanes in the pattern. They had done 2 landings, which were touchdown, full stop, go again. I don't think they were doing touch and go. But in any event, they had gone around twice. This was the 3rd time around. He was on final approach in the Cessna 140. He was behind a Zenith Skull 701. So this is one of the very, very few times that a Cessna 140 might be told to slow down a little bit because he's gaining on the guy in front of him. The 140 appeared to be lower. There's video of this. I don't have the video because I'm always cautious about showing video in a program like this because sometimes the video doesn't work. But he appeared to be lower and gaining on the preceding aircraft. 45 seconds before the crash, the Skull Drag organizer, who was working the radio to help just keep things going here, called on the radio to this pilot and told him, lower your nose, you look slow. Now these guys are by definition trying to fly the airplane really as slowly as they can. They're trying to land on a spot in the least amount of distance. So, and even though they were just doing spot landings, I bet they were still trying for short distance landings still. 45 seconds before the impact, he radios, you look slow, lower your nose. 15 seconds before the impact, the organizer again radios, lower your nose, rather emphatically when you hear the video. So someone looking on the ground who's used to seeing these things is saying, you look like you're getting pretty slow there, you better recover from it. The 140 appeared to pitch up, roll to the right, completed about 3/4 of a spin before it impacted the ground vertically, and looked like this. It was on video, you've seen the videos probably, but it looked like this. 1, 2, 3, 4 is the sequence there. There's some discussion, and again, this is still in the investigative phase, that he may have been attempting to test turn a little bit. But from the video, when I saw it, it looks like it was just basically a sudden pitch up and roll. Didn't think he was really S-turning as much as he just got to the point where the angle of attack and basically rolled right on over. So, what do I write about that? Turns out the same week, my friend Rich McSpattern at the FAA Safety Seminar did an early analysis video. So I'm not going to detract from that very much. It's a really good, similar discussion of what might have happened in this case and what we can learn from it. But this is what I wrote about. Stalls that happen in the traffic pattern are not usually the type of stalls we think happen in the traffic pattern. If you read a lot of my stuff, you know what I'm going to talk about here. But where do you think most stalls in the traffic pattern occur? Where? Base to final. Base to final. Who says base to final? How about maybe even downwind to base and base to final combined? Okay, base to final. That's what we're all taught. Most stalls happen in the base to final turn. In 2017, AOPA's Air Safety Institute published this study called Keep the Wings Flying, Stall and Spin Accidents. And they took a deep dive into a full decade's worth of NTSB reports involving stalls and spins. A little more than half of them occur in the traffic pattern that result in accidents. There's a lot of maneuvering and buzzing type things that happen too, but about half of them happen in the traffic pattern. And when you look at these data, it tells us a very different picture of what the real world stall looks like. So I asked you where you thought the traffic pattern stalls occur, and this is basically where you told me you thought they happened, base to final turn, and maybe, because I suggested it, maybe also on the downwind to base turn. In that decade of accident study, it turns out 3.8% of all of the stalls that happened in the traffic pattern happened in one of these 2 points. Only 3.8%. Now, they are deadly. On the downwind to base turn, if the stall happens there, it's about 66% likely it's going to be fatal. If you're doing the base to final, it's roughly 80% likely. Why might that be? There's no room to recover. If it gets away from you that close to the ground, it's done. Almost always. But only 3% happen at those points. Well, where else do they happen? If you look at their data, after you are on final approach, wings level on final approach, 6.1%, almost twice as many as the base to final and downwind to base, almost twice as many as what we think happen after the airplane's already wings level, but not yet made it to the runway. That's what happened in the case of the 140 here. He's on final approach, wings were level, he just let the angle of attack get too great, and the plane crashed. All right. If you throw in the wings level portions out here, almost never causes an accident out there. 8% of them, or 0.8% of them, they tend to be fatal because there's a little room to recover, but not a whole lot. If you put all of the things on the arrival end of the runway together, we only have 10.7% of all of the stalls that occurred in that 10-year period of time. Now, where are they really happening? 21%, twice as many of all of those others combined. 21% of them happened during the landing flare over the runway. Now, the good news is only 8% of those are fatal. Why would that be? You don't have very far to fall. That's it. We don't usually think of this as being a stall accident. What do we call it? Hard landing. All right. Ran out of air. Remember, I've got a collection of antique flight training books going back to the 1920s. And it was a really common phrase in the 20s and 30s. But the airplane ran out of air. Well, that's what happened here. All right. Put all those together, everything on the arrival side of the airport, and we still only have just under 1/3 of all of these stall accidents. So the real problem happened on takeoff and then a go-around. 18% roughly of them happen in the first part of a go-around. Why might a stall happen in the beginning of a go-around? Yeah, trim. All right, it's not in the the airman certification standards to do on a check ride, but it is in the airplane flying handbook and flight instructor's handbook to talk about something called trimmed stalls. Getting the airplane trimmed for landing and then applying power and causing the airplane to stall. When you apply power, most airplanes will pitch up. If you're trimmed for final approach speed, it will pitch up pretty excessively. So this is one of my big things. I spend a lot of time doing this sort of stuff when I fly with people. But that was almost a fifth of all of the stalls happened in the go-around. And then half of them happened during a takeoff. And this does not include any engine power loss. Engine power loss was excluded from this AOPA study. So the plane is overloaded, or the pilot tries to aggressively pull off, or something happens like the control gust lock or something like that. The airplane stalls. So where pattern stalls really occur, about 2/3 of them happen on the power phase, the departure phase, or the go-around phase. About 1/3 of them happen on the arrival phase where we think they will. We really think that this is where airplanes are going to stall, but this is where they actually stall. So what can we learn about that, from that? Oh, also, we spend a lot of time teaching and practicing power off stalls. Because if there's a such thing as being comfortable with stalls, this is the type we want to do. We spend very little time practicing power on stalls because they're comfortable, they're uncomfortable, they're hard to make an airplane to do, but if it's combined with an FCG or it's combined with trim, a nose-up trim, things we don't normally practice when we're out there at 5,000 feet practicing these things, then it can become deadly. So think about practicing power on stalls. I think we do a really good job overall of avoiding stalls on the arrival end of the traffic pattern because we spend so much time talking and practicing and thinking about power off stalls. But we almost never really think about power on stalls and trim stalls that go around, and you don't practice go arounds and all that sort of stuff, and that's why it misses. So don't stop practicing the power off stuff, just practice the power on stalls. So, what can we learn as an overview from the second mishap? And the third one's pretty short. But this one, don't think you've got it made aerodynamically just because you've turned final. Once you've completed the turn to final approach, you're now in the phase where you have twice as much chance of stalling between that point and reaching the runway, and you've got, on top of that, another 3 times as much chance of stalling in a hard landing once you're over the pavement. So don't think you got it made aerodynamically because you didn't have that basic final turn stall. Practice your power on stalls and your go-arounds at least as much as you practice other types of stalls. Don't focus to the point you reach fixation. That may be a factor in that Cessna 140 in the stall in the short field landing competition. He didn't want to give up. He's well known in the circuit. He's an award winner doing this sort of stuff. Yeah, they're telling me to put my nose down, but I know what I'm doing. I'm focused on the skill, not on the overall safety of the flight. Break off a competition of any sort anytime you start to have an unusual situation, or again, to avoid that fixation. Go around early, go around often. Don't wait until it's too late to begin. Go around. In the Airman Certification Standards, there's actually a statement about go around. One of the skills is to include maneuvering to the side of the runway during go around to avoid other conflicting traffic. I learned this in the Air Force in flight screening a long time ago, but we don't seem to do that much in the real world these days. This is what a go-around is supposed to look like. You're behind somebody, you should sidestep off to the side, so if they decide to do a go-around themselves or they do a touch and go, they're not climbing up into your belly as you're trying to fly over them. So keep them inside. Third mishap. This one's we'll go through it fairly quickly. Okay, he just reset my time, so that gives me, I'm good. All right, flag wave. All right, this one's a pretty short one, but this was a Piper PA-30, a twin Comanche. It happened in Concrete, Oklahoma, which is very northern Oklahoma, almost to the Kansas border, last March. This one also is still just preliminary information. Well, what happened here? The aircraft departed from Mineral Wells, Texas, which is west of the Dallas-Fort Worth area, at about 3 in the afternoon local time. It's winter time, or March. So, all right. The aircraft tracked north and climbed initially to 8,500 feet. It's VFR. It's a VFR flight. Turns out the pilot was not instrument rated. It later climbed to 16,500 feet. There's kind of a red flag, but it did. And there was no ATC contact in the NTSB preliminary report. They took great pains to say it was not required that they be in contact with ATC. That's not really considered a factor here. About over Vance Air Force Base in Enid, Oklahoma, which is only maybe 60 miles south of the Kansas border. So they're along a little ways. We'll see on a map here in a minute. The airplane began to descent from the 16,500 foot altitude and turned east initially, then it turned west and then back north as it descended. The ground speed during this time decreased from over 200 knots to under 100 knots ground speed. All right, we're talking ground speed here is measured on radar. So if the airplane has a very rapid rate of climb or descent, it's not making a lot, it may not be making a lot of distance across the ground. So the airspeed, the ground speed was varying quite a bit up here. The aircraft was lost from radar tracking at about 4:38 in the afternoon. It had been in the air about an hour and a half. This is what the track looked like. Mineral Wells up to the Enid, Oklahoma area. An initial jog to the east, then to the west, then back to the north, and then loss of control. Close up on the final portion of the flight looked like this. Coming up like this, made that west turn, or east turn, made a direct west turn, then north, and then eventually more or less straight down. A witness on the ground saw this airplane coming in, heard first what sounded like engines revving, saw the